In this video, I am going to discuss about a very important topic which is known as time dilation theory, or sometimes it is also known as apparent retardation of clocks. Now, to understand this one, at first let us consider two distinct frames of references. One is say S, another one is S dash. Now here you can see S dash is moving with some velocity v relative to S in the positive direction of x-axis as shown in the diagram. Obviously O and O dash are nothing but the two origins corresponding to S and S dash respectively. Now let us assume a certain clock is placed in the first reference system, that is in S, which is supposed to be at rest, and also let us assume that this clock provides a signal at certain time t1. Obviously this time is measured or recorded in the first reference frame, that is in S. Now if possible, there exists an observer in S dash who records the same event at some time t1 dash. That means for observer the time seems to be t1 dash, which was supposed to be t1 in the first frame of reference. Now if we apply the concept of Lorentz transformation, then we will get a relationship between t1 and t1 dash, which is nothing but t1 dash is equals to t1 minus vx1 by c square by whole divided by root over 1 minus beta square. Now obviously you can understand what is the meaning of beta. Beta is nothing but v by c. V is the relative velocity of the observer and c is nothing but the speed of light. Now again, if possible, let us assume the same clock provides another signal in the reference frame S in time t2, and the same thing is recorded by an observer in S dash in time t2 dash. Then again applying Lorentz transformation, we will get another relation between t2 and t2 dash. So that is given by equation number 2. So we have obtained two distinct relations. One is equation number 1, another one is equation number 2, providing the relationship between t1 and t1 dash and t2 and t2 dash respectively. Now if you have any doubt regarding the expression for t1 dash and t2 dash, you can go through my first video where I have explained everything about the reduction of Lorentz transformation equations. So after getting these two expressions, we can easily understand the change or length of the time interval corresponding to the first frame of reference is nothing but t2 minus t1, which is supposed to be del t. And the same thing whenever you are measuring the same thing in the second frame of reference, that in S dash, that will be what, t2 dash minus t1 dash, that will be equivalent to del t dash. Now simply subtract equation number 1 from equation number 2. Then you will see the left hand side will give you t2 dash minus t1 dash, and on the right hand side you will see vx1 by c square will be cancelled, so that you will get t2 minus t1 whole divided by root over 1 minus beta square, as I have mentioned here. Now this thing left hand side can be redefined as del t dash, because already we have said t2 dash minus t1 dash is equal to del t dash. So on the right hand side the numerator will be modified as what, del t. As you can see, I have written the same thing, whole divided by root over 1 minus beta square. But as mentioned earlier, beta is what, v by c. Consequently beta can be replaced by v by c, so that it will give you del t whole divided by root over 1 minus v square by c square. Now obviously you can take this one to the numerator portion. While taking this one to the numerator portion, it will be converted into 1 minus v square by c square whole to the power minus half, and consequently you need to expand it using binomial theorem. So here in the next page I have done the same thing. Del t dash is equal to del t multiplied by 1 minus v square by c square whole to the power minus half. Here you can see I have neglected the higher term, so expanding by means of binomial theorem, we have obtained equation number 3, which states that del t dash, that is equal to del t within bracket 1 plus v square by 2c square. Now obviously this expression is greater than 1, and consequently you can say del t dash must be greater than del t. That means you can see from this relation that the time interval del t appears to the moving observer to be dilated. Dilated means gradually it becomes lengthy by means of a certain factor 1 by root over 1 minus beta square. But already beta is mentioned as v by c, so it will be equivalent to 1 by root over 1 minus v square by c square. And the process of this time interval to get dilated is nothing but known as time dilation. And this is a very important phenomenon in case of classical theory of relativity or special theory of relativity, you can say. And also we can say that a moving clock always appears to go slow, and this is the very important conclusion which we can understand from this article. Now for instance, if we consider V is very close to C. That means if we take V is equals to 0.999 C or even 0.99 C, then you can see del T dash will be given by del T by root over 1 minus V square by C square. So if you calculate by putting the value of V in this expression, then you will see del T dash will be what? 22.7 years. That means anything or any person which is moving with this velocity, which is very much similar to the speed of the light, and any apparent observer who will try to observe him or her will see after certain time, it will be after 1 year. In case of static observer it will be fixed, but in case of moving observer it will be 22.7 years. And obviously in case of time dilation, one important relation is that whenever you are considering the velocity of the particle, then it should not be negligible in comparison to the speed of the light. This is the most essential condition, and that's why in this note you will see I have given certain conditions to realize when time dilation theory is effective. So in your university question you will find this concept to explain the time dilation theory or briefly discuss about time dilation. Then you can utilize this article to give your answer, and hopefully this article will solve your purpose. Thank you.